Welcome to LDI 1.13 or LDI 113. Good idea you work examples 1-9 on through the book before you watch this LDI, but if you've done that already and you still need some help, well, let's get after it here, okay? So we're going to take a look at a couple of smooth distributions. We have machine A and machine B, which produce parts, okay? And this is a distribution of the lengths of the parts produced by these machines. So what they tell us here is that machine A makes parts whose lengths average around 4.6 millimeters, and machine B, they make very similar parts, but they have a higher average length of 4.9 millimeters. And that's represented in our graphs here by noticing that the center on this graph is around 4.6 and the center on this graph is around 4.9. Whereas the most common length of a part from machine A is about 4.6 millimeters, and the most common length, or what you'd expect to see from machine B, is 4.9 millimeters. Okay? So you have a part and you think a box of parts and you think those came from machine A, but you're not sure. So you're going to test the hypothesis by randomly selecting one part from the box and measuring it. The null is that it is as you thought, it's from machine A, and the alternate is, well, it's not, it's from machine B, okay? So we need to first of all find out our direction of extreme. So is it one-sided to the right, to the left, or is it two-sided? So let's go take a look at our plots here again. We'll notice that using that little trick that we've done earlier in the class, if we take the null and we mark that on a number line, and then we mark the alternate on a number line, what we see is that the alternate is to the right of the null, isn't it? It's shifted to the right of it. Therefore, what that tells us is that we're going to be one-sided to the right, aren't we? Okay, so I'll circle that one right there. Okay, so now they're going to give us a decision rule. And they say the selected part is 4.8 millimeters or more extreme. In the picture, shade the region that corresponds to alpha and shade the region that corresponds to beta. Okay, so let's go back and do that. Let's take just a quick moment here and clean up our mess here, get rid of that. Okay, so if we're going to shade the regions, I'm going to go ahead and do that with my highlighter here. Let's go ahead and shade the region that corresponds to alpha. Well, let's remind ourselves real quick what the decision rule was. It's 4.8 millimeters or more extreme. So our critical value is right here. That's 4.8. That's our CV, or our critical value. And so what that tells us is that's the cutoff value for the rejection region right there. Okay? So let's go ahead and highlight that rejection region in red. Okay? So this shaded region right here will correspond to alpha. Okay? So that region right there is alpha. Okay. Let's take put a line down here, connecting it goes from there to there. That's alpha. Okay. All right. So now they also want us to do beta. So let's go ahead and get the corresponding value of beta. Well, remember it's 4.8 again, but this time since we're doing beta, it's in the distribution of the alternate. Okay. So we'll go ahead and draw ourselves a line of demarcation in the alternate here. And remember that beta is going to be in the opposite direction of alpha. That's kind of a trick, but the thing is you got to think about what beta is. It's the probability of making a type 2 error. That is rejecting the alternate when in fact it was true. Well, when will that happen? Well, that happens whenever we select a rod that is smaller than 4.8 millimeters. Okay, so let's go ahead and shade in this region. We'll use red here also. And this shaded in region right here, well, that's going to correspond to the value of beta. Okay, so that's beta in our picture. And again, just to make ourselves perfectly clear here, we'll go ahead and mark ourselves a line over there. Ooh, I'm going to do that one in red even, okay? All right, so now we've got alpha and we've got beta in the picture, and they tell us that our selected part length that we selected here was 4.7 millimeters, okay? So our observed value is 4.7 millimeters, and they want us to shade the corresponding value of the p-value and label that region with the p-value, okay? So let's go do that. So the value was 4.7 millimeters, so our observed value was at 4.7 millimeters, okay? Get my pen here to mark it. So this value right here, that's the observed value, and now we're going to calculate a corresponding value of the level of significance based upon our observed value. That's what the p-value is. So let's go ahead and we'll do that one in yellow. Okay. Now here's where a little bit of confusion comes when people do this for the first time, is that, I want to do that in the highlighter, excuse me, is that what you're doing is you're shading not just the region between your observed value and the critical value, but you're doing all of the shading. You're shading over everything. So this, notice it keeps on going, okay? It gets over right over the top of alpha, okay? All right, so let's come up here. Oops, this one, I don't want that, I wanted this. Let's get rid of that smudge I just made up there. Okay, I want to get my tool to write some letters here, and so, okay, that is the p-value. Okay, get the line tool here, and we'll come down and we'll mark ourselves with a line down corresponding to the p-value. Okay, now just to make it so possibly it's a little easier to see, we'll come back with the highlighter just a bit, and we'll do a little bit more highlighting with some red here, just to kind of get the idea. Okay, that alpha is still there, it's just overlapping with the p-value. Okay, so hopefully that all makes sense. Very pretty, I know it's a pretty picture. Okay, so let's go see if we can answer the question now. What they want us to say is the selected region, or is the selected result in part C statistically significant? Okay, give you a second to think about it. You tell me which is bigger, the p-value or alpha, based upon that picture. So in other words, I'm going to come over here. I'm going to put down p-value. Again, put the right symbol between there. So I got p-val and I got alpha. Okay, and what I want you to tell me is what is the appropriate inequality symbol to put between those two. Hopefully you saw that the appropriate symbol to put between those two was a greater than. Okay, and since the p-value was greater than alpha, and now we're so hot on the information given to us on page 32, we know that what? That the selected region in part C was not statistically significant. Okay, and to explain your answer, how are you going to explain your answer here? Well, it's pretty straightforward. What you're going to say is that the p-value is greater than alpha. Greater. Okay, well, hopefully that all makes sense and you're getting the hang of this stuff, and we'll see you all back soon for some new LDIs in Chapter 2.